Okay, I want to talk a little bit about x and y intercepts here. Now, x and y intercepts are going to be a big reoccurring theme in this class. We're going to talk a lot about x and y intercepts, just like we're going to talk a lot about domain and range, okay? So what are x and y intercepts? Well, let's start by looking at a graph. So if I sketch a graph, okay, here's the y-axis, here's the x-axis. Remember, this is our Cartesian coordinate system. And a graph is just a visual relation. That is, it's a way of relating different x and y points together. So if I draw just a funny looking graph, maybe it looks like this, okay? So here's a funny looking graph. Okay? Turns out this is the graph of a function. How do I know? Because that vertical line test. I can think about the domain and range of this. The domain is going to be everything. This is eventually going to cover all of the x values. Our range would be negative infinity to 2 because there's no y values above 2. What I really want to talk about now is I want to talk about x and y intercepts, okay? Well, intercept is a word that means come together or cross or touch. So when we're talking about x and y intercepts, we're talking about where our graph would cross or touch one of the axes. Okay? So in particular, if we're talking about an x-intercept, an x-intercept is any place that our graph crosses or touches the x-axis. So while I finish writing this, look over here and say, does our graph cross or touch the x-axis? Where? Well, what do you think? Well, here's our x-axis. It's our horizontal axis. Our graph is crossing the x-axis at two places, here and here. Now, if we want to describe those, we would use ordered pairs. The ordered pair here is -3, 0, and the ordered pair here is 2, 0. So our x-intercepts for this graph would be -3, 0, and 2, 0. Okay. Now, similarly, what do you think about y-intercepts? Well, y-intercepts are going to be anywhere that our graph crosses or touches the y-axis. Okay, so looking at the graph, if I get out of the way, where does this graph cross or touch the y-axis? Well, it's crossing the y-axis right there, so our y-intercept would be the point 0, -2. Okay? So we can look at a graph and see where it crosses or touches the x-axis to find our x-intercepts, and where it crosses or touches the y-axis to find our y-intercepts. Now, I'm going to draw another graph up here. All right, so here's our next graph. Okay? Let's think about the x and y intercepts for this graph. So remember, our x-intercepts are any place the graph crosses or touches the x-axis. Well, here the graph is crossing the x-axis, so our x-intercept would be at -2, 0. Y-intercepts are any place our graph crosses or touches the y-axis. So it looks like we've got y-intercepts here, here, and here. Let's give each of those a label. So this is the point 0, 3. This would be the point 0, -1. And this would be the point 0, 1, 2, 3, -4. Okay. So here are some more examples of x and y intercepts. Now let's see if we can make some generalization. When we're looking at our x-intercepts, right, you may or may not have noticed that every time we have an x-intercept, our y-coordinate is 0. See if that makes sense. Remember that in an ordered pair, the x-intercepts tell in an ordered pair, the x value tells us how we move horizontally, move along the x-axis, and our y-coordinate tells us how we move vertically. Well, an x-intercept has to sit right on the x-axis. That means we can't move up and we can't move down. In other words, our vertical coordinate has to be 0. Turns out that's another way to identify x-intercepts. X-intercepts always have the form, a number, in our x-coordinate and 0, okay? In other words, y is always equal to 0 for an x-intercept. As we move on and try to find x-intercepts and y-intercepts, setting y equal to 0 is going to be one of our techniques for doing that. Now let's think about y-intercepts, okay? We happen to have 3 y-intercepts up here. And notice that for each one, the x-coordinate is 0. Let's think about if that makes sense. In order for something to be a y-intercept, it needs to be sitting right here on the y-axis. Well, that means it can't move right and it can't move left. In other words, it can't move horizontally which says exactly that our x coordinate has to be 0. So similarly, y-intercepts are going to have the form 0 and then a number. Okay, so a number in the y spot, 0 in the x spot. In other words, x equals 0 is going to be a hallmark of y-intercepts. And it's also going to be a way that we find y-intercepts later on. Okay? All right, let's see if we can use that to continue thinking about x and y-intercepts, not necessarily in graphs, but in lists or tables. All right, let's say we're given this nice table and told that it represents a relation. We can tell that this table is a function. How? -3, -2, 0, 1, 3. None of our x values repeat, meaning none of our domain values can be doing double duty. Okay? So this is a function table. Let's see if we can use this table to find out if there are any x-intercepts listed or any y-intercepts listed. Well, x-intercepts, remember, have this form. X, 0, a number, and 0. In other words, y is 0. So if I look at our table, hey, look, here y is 0. So this row of our table represents an x-intercept. The x-intercept 3, 0. How about y-intercepts? Well, y-intercepts have that hallmark 0 in the x position. So if I come down here, here's 0 in the x position. So this is representing a y-intercept at 0, 12. Okay? X-intercepts and y-intercepts. We need to be able to find them. We need to be able to recognize them and understand some of their properties.